Episode 9, Suspended Slab. The episodes of building construction supervision are meant to teach anyone. Prior knowledge of building construction is not necessary. A suspended slab is a thick plate that supports loads through its bending strength. We will restrict ourselves to a reinforced concrete slab in this episode and look at issues to take note during construction. I'm your tutor, Engineer Wilson Chirwa. Suspended slab supports. A suspended slab may be supported on beams or walls on its sides. A slab may be supported on all four sides or just two sides. The distance between the slab support is called a span. A slab spans one way if it is supported on two opposite sides. When a slab is supported on all four sides, then it spans in both directions, provided the length LY is not more than 3 times the width LX. Where the length is more than 3 times the width, it is taken as spanning one way. In that case, the width LX is its span. The dimension of the span is taken as distance between the support center lines. Simply supported. A slab is simply supported when it rests on a beam or wall support. Continuous slab. A slab is continuous when it proceeds beyond its second support onto another support. The minimum number of supports for a continuous slab is 3. Cantilever slab. A cantilever slab is a continuation of a slab beyond its support. The cantilever is not supported at its end. Balconies can be constructed as cantilevered slabs. Slab formats. Slab and beam arrangement. In this format, the slabs are supported on beams. Slab thickness can be reduced by reducing the span. Generally, the slab thickness is from 150 mm to 250 mm depending on span. Slab and beam format leads to high story height as airflow ducts have to be positioned around the beam. Flat slab. The slab is supported directly by columns without any beams. Columns tend to punch through the slab. Hence, the slab is thicker. The thickness varies between 250 to 400 mm depending on the spacing of the columns. Columns may be constructed with column heads to improve the punch shear capacity, leading to a thinner slab. Disadvantages of flat slabs are that they tend to deflect excessively and suffer vibrations if slab is thin. Advantages include shorter story height and easy installation of air ducts. Ribbed slab is a slab that has closely spaced beams or ribs supporting it spanning in one direction. Beams are spaced between 900 to 1200 mm centers. The slab, which is reinforced with mesh bars, is 75 mm thick. Ribbed slabs enable large spans to be achieved. That is desirable where uninterrupted large spaces are required, such as shops, conference room, display areas, etc. Coffered slab is a slab supported on closely spaced beams spanning in both directions. The beams are spaced from 900 to 1200 mm in both directions. The slab is not less than 75 mm thick and reinforced with mesh bars. Coffered slabs achieve greater spans in both directions, allowing for large uninterrupted space. Coffered slabs have thickenings at columns for punch shear resistance. The thickenings are as deep as the column ribs. Load reduction. Both draft and coffered slabs result in reduced slab weight and therefore reduced loads on columns and foundations. Since the majority of the reinforcement in a slab carries the slab weight, troughed and coffered slabs offer reduced reinforcement costs. Reinforcing topping. The trough and coffered slab is reinforced with mesh reinforcement of 6 to 8 mm diameter. The mesh is positioned near the top of slab. Fire resistance. Screed on top of the slab helps improve fire resistance. The slab thickness can be increased from 75 to 100 mm to increase fire resistance if the distribution of floor screed is ignored. Formwork issues. Levelness. The formwork for beams and slabs should be truly horizontal. To achieve that, the formwork should be strong enough to span between supports while carrying wet concrete. In addition, the positioning should be within dimensional tolerances. Props. The props supporting the formwork should be strong enough to take the weight of formwork and wet concrete. Water tightness. The formwork should be tight enough to prevent water oozing out of wet concrete. Reinforcement. Function of reinforcement. In a slab, the reinforcement resists tensile forces that result from the bending of the slab as it supports loads on it. Compressive forces would generally be resisted by the concrete. In the absence of reinforcement, or if there is insufficient reinforcement, the slab would crack and collapse. Reinforcement position. Near the middle of each span, the slab experiences tension at its lower depth. Hence, main reinforcement is positioned near its bottom. At the supports, the slab experiences tension near its top, resulting in main reinforcement being positioned near the top. As a preference, there is top and bottom reinforcement throughout the slab in both directions to contain stresses that result from earthquakes. Sizes of bars. Sizes of bars range from 10 mm diameter to bigger depending on span. There are also bar stools for positioning top reinforcement. Curing slab. Curing concrete is the process of protecting the concrete from moisture loss and maintaining its temperature at a suitable level for hydration, i.e. chemical reactions. In the process, the concrete is prevented from premature drying as a result of wind or high temperatures. After 24 hours from casting, the slab is covered with a layer of sand and sprayed periodically with water to keep the sand moist in warm or hot weather for 7 days. The concrete slab is covered with waterproof or plastic sheeting firmly anchored at edges in rainy weather. The sheeting should be removed after the rains have stopped. The covering is meant to protect the fresh concrete within the first 24 hours. Further information can be accessed in a book I have published available on Amazon entitled Building Construction Supervision.